This is a gate problem from analog electronics module for the ECE paper, and this question appeared in this year's gate. So this is a problem from analog electronics, and it is stated that the Vout by Vin of the circuit shown below is, first option is negative R4 by R3, second option R4 by R3, third option 1 plus R4 by R3, and last option is 1 minus R4 by R3. So this is the topology. This is a 3 op-amp topology, and if we can break it down to its basic topologies, this is a very simple problem to solve. This is a problem that carried 2 marks, and so the basic topologies are that of the inverting amplifier, the non-inverting amplifier, and the inverting summar or inverting adder circuit. So let's just revisit our understanding of the inverting amplifier. So this is the topology for the inverting amplifier. The non-inverting terminal is grounded, input is applied through RA, and then there is another resistance named as RB in the negative feedback path. So the output voltage is given by negative of this feedback resistance RB divided by this input resistance RA multiplied by the input voltage Vi. Next is the non-inverting amplifier. So here the input is applied to the non-inverting input terminal, and the feedback resistance RB is again present in the form of a negative feedback, and this is the resistance RA connected to ground. So for this topology, the output voltage Vout is given by 1 plus RB by RA multiplied by Vi. And the last one is that of an inverting adder. So if you keep on adding branches to this input terminal, then the inverting amplifier turns out to be that of an inverting adder circuit. So we have 2 branches here, and the feedback resistance is given by RC, and the input voltages are given by V1 and V2. So the output voltage is equal to negative of RC divided by RA multiplied by this input voltage V1, and again negative of RC divided by RB multiplied by V2. Note that this term inversion is because the input is applied to the negative input terminals, and so the output will be a opposite version or opposite polarity of that of the input. So going back to the original circuit which was given to us in the question, we can identify that this top operational amplifier topology is that of an inverting amplifier. The next one, this one, is that of a non-inverting amplifier. And finally, at the output side, we have an inverting adder configuration. And so all we have to do is to plug in the values for the formulae. So if we consider that the output of the first op-amp is V01 and the output of the second op-amp is V02, then we can write V01 as negative of R2 by R1 multiplied by Vin. This is the inverting amplifier. And the second one, this one being that of a non-inverting amplifier, we expect that V02 should be equal to 1 plus R2 by R1 multiplied by this input voltage Vin. And then we can proceed and write this as Vin plus R2 by R1 times Vin. And finally, looking at Vout, we know that this is that of an inverting adder, and therefore Vout is given by negative of R4 by R3 multiplied by V01, negative of R4 minus divided by R3 multiplied by V02. And then substituting V01 and V02 from the first 2 equations, if we do this substitution, it is very easy to show that V out is equal to negative of R4 by R3 multiplied by the input voltage. Now, because they want the answer in the form of V out by V in, so this is simply equal to negative of R4 by R3. And so option A is the correct option for this problem. So in this question, they are testing your understanding of the three basic amplifier topologies, which is that of the inverting amplifier, the non-inverting amplifier, and the inverting adder circuit.